I will be talking also about digital twins of the ocean. My name is Ute Broenner. Maybe a quick short introduction for me. First of all, thanks for having me. I'm very humbled that my name was actually mentioned 2 times here already, and that is probably because I'm leading this work group 5 within DTO, Digital Twins of the Ocean, and we call this is an endorsed project, and we call that Turtle. And when we started and all this digital twin development started, I was one of those talking to Martin and say, we need to facilitate that all these projects talk to each other. Otherwise, this won't work. And then Jay Perlman, who many of you might know, say, yes, Ute, you do that. And so many know me now. This is nice because I'm based in Norway, in Trondheim, which sometimes feels a bit off from the rest of Europe working with digital twins. But I'm working in another digital twin project, which we call Iliad. And Iliad is it has a complete different approach to digital twins of the ocean, which I find very complementary to EDITO. So this works very nicely. We are in great contact and collaboration. So we try to be interoperable for sure. And the idea of Iliad is more like we make a central digital twin of the ocean available to everyone, but more like there are so many scientists and environments in Europe working with development of digital twins. Let's try to bring these together to create digital twins of the ocean, and not the digital twin. We work with very localized twins, so we do not do like big marine spatial planning for the whole of Europe or a whole ocean basin. We also do not do big ocean models, climate change models. We are happy to use them in our pilots because, as I said, we work very localized. A bit more about me, I work in a department that's called Climate and Environment. So my why to work with digital twins is really like build digital twins to be able to operate in the ocean in a sustainable way, which is why I included this overshoot donut, which you might have heard about. So we have to make sure that we have an ocean that we can operate in the future. And I work at SINTEF, which is it's a research institute which is very close to the industry. And I want to tell people, how can you do and work in the ocean and still be within the limits? So that was the wrong direction. We have heard what digital twins are. I just want to add that I like my digital twin when I develop one, also to react to the data that it analyzes all the time. So it updates all the time and it's models, but I kind of want the digital twin to be so smart to react. And that can be simple things. It's just, okay, something happens, now we have to measure more often than we did before. Or something has happened, we see that in the data, so we run an extra model to get additional data, data for decision making. Yes, and we have heard why we're doing this. We want to be able to create these what-if scenarios. We want to study things in the ocean without breaking it. So I can put as many wind farms in the ocean wherever I want in my digital twin, and I can study first what might happen, and then I can make the decisions based on it. So, which is also often that we bring together data that hasn't been brought together before. So now we might be able to see aquaculture in correlation with agriculture, for example, and see their combined effects on the ocean and plan them together. We can put these, look into marine industry parks where we might have co-location of aquaculture and wind farms, and then there's shipping and there's fisheries, and everybody has to operate in the same ocean space, and we see that space in the ocean is getting sparse. We also want to have marine protected areas, so everything has to be brought together and looked together in digital twins. So back to Iliad. In Iliad, as I said, we work with very localized twins. And we have so-called pilots, that these are our demonstrator cases, and I'm responsible for the work package to demonstrate these pilots. So as you see on this map, it's heavily populated. We have 22 pilots currently operating, and they are very different. So we have some pilots which are PhD projects, and they are kind of looking at cutting-edge technologies, really bringing new things, looking at new machine learning models, for example. We have end user projects. So we have partners who said we would like this for our industry. This can be insurance, this is wave power, this is tidal energy. And we have the technical partners in the project who also drive pilots and who are really developing the components that build up digital twins in the end. So we go from data acquisition, and then you have to have the infrastructure to handle all this data. Then you have the digital twin core that does something that you want to study. And then you have the visualization and all these things. When we started Iliad, and also when Edito started shortly after us, nobody was really doing digital twins in this professional way. So this is, everything is in the making and what we're doing. So as I work with environmental risk assessment, environmental monitoring a lot, and we also have something that we call an ocean lab. I have a pilot that is going on environmental monitoring. We call it short the water quality pilot. And the reason for that is that I'm based at this beautiful Trondheim fjord, where we have an ocean observatory that is not connected to any of the ocean observatories that we have in Europe. So we are not providing data to EMODNet yet, so to speak. And of course, I want to change this, but this was a unique possibility for us to learn how to do this. What do we have to do with our data? And how can we build a digital twin for this ocean lab? So we use two nodes. We call them nodes. I don't like that very much, but there are two study areas. One is an ocean observatory. So we have two strategically placed surface buoys for ocean observations. And we have two subsea nodes, which are dedicated to underwater robotics, but they are also collecting a lot of data. And we want to bring this together. We are not the super skilled people for user interfaces. So, and this is not working. It's supposed to be a video. Do I have to do something? Oh, there you go.
Yeah.
So, we always put a disclaimer on our page. These twins are not yet validated or something. So it's a disclaimer. It's still under development. And we are looking very much into particles in the ocean, what might happen in the ocean, and where might these particles be transported. So on the map to the left, you can see we have these four stations. Now at the top, you see the weather and the Munkholmen buoy, which is, or the Munkholmen island, which is called Munkholmen. This is the Ingdalen buoy at the entrance of the fjord. And then you have these two subsea landers on the sea floor. We had a plankton or a particle camera on the Munkholmen buoy, and we have observed particles in the ocean. On the other side of the fjord is there is a harbor. There's a lot of marine litter ending up there. And where the mouse is now, there are a lot of bathing places, actually. So we're a bit concerned about water quality. I will shorten this now. So we combine this with several transport models to see where the particles end up. And then we can do something like simulation of dilution. We can do simulation of transport. And we bring this all together in this map. And you can then look at the different maps and visualization. So, but why particles? Everybody is asking me why particles. So now you see video uptakes from the video recordings from the subsea lander that's on the seafloor. And we have this beautiful monkfish, and we have the crown jellyfish there, but we also see a lot of particles. And we are very concerned about, are these particles that belong there? So you see fish egg or copepods in the images below, or are these particles that we don't want there? And this can be oil droplets, microplastics, but it can also be something like viruses, salmon lice, and these kind of things, which brings me to the other pilot, which is aquaculture. So we now have used the same approach of modeling particles for smart monitoring of the Norwegian aquaculture industry. So we look at the whole aquaculture industry, and we bring together openly available data and combine that with ocean modeling to do something and be able to warn the aquaculture industry of some things that might happen. So aquaculture is the second largest industry in Norway, and usually it works very well, but there are a lot of problems. There are salmon lice, there are infections, and there is now this new string jellyfish that is really causing problems and leads to a lot of loss for the industry. And that is, even if you don't like aquaculture, it's a lot of dead fish and food waste. So we really want to bring this pilot together now by using openly available data that can you get from this site. It's called Balance Watch, and it collects all the data that the aquaculture operators in Norway have to report once a week. They have to report oxygen temperature, but also infection and lice counts. We have actually two interfaces right now. Again, I said we're not the greatest one at user interfaces. It always starts in our own aquaculture site, which is called Tristeinen. And then it looks into connectivity potential between this site and the closest sites around it. So now the modeling trajectories that you see indicate that this site does not have fish right now, which is why I'm picking another one now. It's another SINTEF one, it's called Rataren. So now the digital twin will update with the latest trajectories and the connectivity between the closest site to Rataren. And if you scroll down and look at the map, you see when the trajectory of one site goes into the other site, then this is something that we call connectivity. And then this is only the modeling part. Then we wanted to make our digital twin smarter with adding as much additional data as possible to give more contextual data. And then we also asked people who are a bit smarter at making user interfaces. And now this is a pilot that works for the whole of Europe. So all aquaculture sites are there. What you currently see are the weather warnings. We actually had snow this week, so there were weather warnings on marine icing. You can filter the sites without fish, and you can choose between day and night, so it makes it a bit more modern. And of course, you can also then have these trajectory simulations as well. Here, the interface works like you can click on the map and choose your 2 locations or several locations. And then if you scroll down below the map, you will see the data and the connectivity between these sites. And then you can work with that data, and you have this little connectivity matrix if they are related to each other. This is very important. There are actually very, very many people working with this right now. If you choose only one location, you get the weather forecast for the ocean and the weather forecast for the air, meteogram, marinogram, and a bit more data, wind forecast, for example, if you're planning operations. So this is very useful. Another feature is that you also see the organizations who are operating this. So now you can write SINTEF Ocean. As I told you, we have 5 locations with salmon ourselves for research purposes. And then you can filter the whole thing by the operator. This is then also important when you want to expand this pilot, for example, and add more statistics, which might become relevant for other things like insurance, for example. So on one hand, I want to be able to filter by a specific company to give them better prices, but I also want to create a solution that gives the aquaculture operators themselves incentive to become better. So I want to give them a location ranking saying you are among the 20 best in your area, for example. Or I want to give them the opportunity to compare that last year you were in this situation, in a similar situation, and you might have for that by great mitigation actions. So I give you the comparison when you were in this situation before. So this is how it works right now. We are also looking into gaming technology for visualization. As I said, so our visualization rate is really the minimum. So we work together with the Broenner University, who's really good at gaming, and they have this for the particle. They have this Unity visualization of particles in the ocean, and they have also made the water quality pilot a bit nicer. But what they also have come up with is something that we call the procedural ocean. And that is now that you can configure an Unreal gaming environment from the digital twin. So you can now create an input file to the Unreal Engine that will create this scenery for you. This has been made for the wind energy now, and we want to use that for aquaculture as well. And I think it will be very powerful if we can visualize the trajectory and the connectivity between sites as a heat map on the ocean, for example. So this is all something that is in operation between the digital twins in Iliad. And as Pierre said, so we are working very closely. You see that Iliad is here at 2 places, and this is why we have this little different approach to digital twins. And the social ecological data came up earlier as well. So one of the, if I go back here, one of the aspects here is social ecological data that is now coming into the digital twin ocean. So I will start a project after summer. It's one of the 4 that Nicola mentioned. It's called DTOs. And there we, of course, want to reuse the work that we have done in the digital twin projects and in other projects of the mission. And we work, for example, with one case, which is creating one of the biggest wind farms in one of the smallest, or the smallest island community in Norway. But we also look at co-location and marine spatial planning together with the changing scenario to the heat in the Baltic Sea. And I think that was it from my side. Thank you very much.